Hello everyone, today we're talking about trig functions of real numbers, section 5.2. So eventually you're going to need to know this chart. You're going to need to know the values for sine, cosine, tangent, cosecant, secant, and cotangent. And we'll talk a little bit more about them as the lesson goes on. But like I said up here, I have a real easy way for you to know these values as long as you have the unit circle memorized. So just like we did in class today, as long as you've got that unit circle memorized, this chart should not be that difficult. So the same unit circle that we looked at before, you'll see the cosine corresponds to the x value of each of my points. The sine corresponds to the y value of each of my points. So that's why I'm saying as long as you have the unit circle memorized, any one of these given angle values, you should be able to know the cosine and the sine of that specific angle value. So I'll show you some examples. The first one, they want us to find the exact trig function, exact value of the trig function at a particular number. So this one here, sine of 5 pi over 6. So first thing we're going to do is find the reference number like we did today in class. So 5 pi over 6, remember this is 0, this is pi. So 5 pi over 6 is going to be in the second quadrant with a reference angle of pi over 6. So we know that we're really finding the sine of pi over 6. But we're in, so it's kind of like we're doing the sine of pi over 6, but we're in the second quadrant. So in the second quadrant, I know my x is going to be negative, my y is going to be positive, and since, if you look at your unit circle, the sine is my y value here, since we're in the second quadrant, my sine is going to be positive, right, because the y is positive. Then, all I need to know is pi over 6. So pi over 6, the y value is 1/2, right, because pi over 6 is equal to radical 3 over 2 for my x and 1/2 for my y. So the sine value just wants the y of pi over 6. So my answer is 1/2, and it's going to be a positive 1/2 because y is positive in the second quadrant. Next, sine of negative pi over 6. So I always like to start off by drawing. So negative pi over 6 just means I'm in the fourth quadrant with a reference angle of pi over 6. So since the reference angle is the same here, we know my value is still going to be the same of 1/2, but since I'm in the fourth quadrant, the sine value is going to be negative. Since sine corresponds to y, cosine corresponds to the x values. So this sine of negative pi over 6 is a negative 1/2. Since negative pi over 6 is in the fourth quadrant and y is negative in the fourth quadrant. And just to reemphasize, this is really sine of 5 pi over 6, but we use the reference angle pi over 6. So and the sine corresponds to the y value of that. Next question. Next thing you're going to need to know these identities. So this is something we have not covered yet, so you're going to want to make sure you get those down. All it's saying is sine is equal to 1 over cosecant, cosine is equal to 1 over secant, tangent equal to 1 over cotangent. And then obviously vice versa. A couple other things you want to know. Tangent is equal to sine over cosine, and cotangent is equal to cosine over sine, with a couple of these Pythagorean identities that you're also going to need to know. So I'd make sure I had that chart copied down, and then we're going to go ahead and find the sine, cosine, and tangent of this point. So to start off, sine of t, whatever t may be. They didn't tell us the angle, but that's fine. We don't need to know the angle. We just know that sine of t, sine corresponds to the y value. So my sine of t is a negative 2 radical 2 over 3. Sine is the y. Cosine of t is the x value. So I get a negative 1/3, the x value of my point. And then tangent of t tangent is equal to the sine of t, or sine of x, sine of t, same difference, divided by cosine of t. So, since that is equal to sine of t divided by cosine of t, just plug in what I know sine of t to be, negative 2 radical 2 over 3, and negative 1/3. And when I go ahead and do that division, remember I can flip and multiply, so I really get negative 2 radical 2 divided by 3 times negative 3 over 1. These cancel. There's a negative times a negative, so I'm going to get a positive 2 radical 2 for my tangent of t. I had a negative 1/3 for my cosine, and a negative 2 radical 2 over 3 for my sine. Now, they want us to write the first expression in terms of the second. So that means I want cosecant of t to be equal to a value that only has cotangents in it. I can only have cotangent on the right-hand side. Also, they want us to know that we're in quadrant 3. So to do this, I'm going to use my Pythagorean identity that the cosecant squared of x is equal to 1 plus the cotangent squared of x. So I'm going to start with that. Alright, but it wants just the cosecant. I can't have a cosecant squared. So I'm going to take the square root of both sides, and I get the cosecant of t is equal to the square root of the cotangent squared of t plus 1. So this one was a pretty basic example. I had a real easy Pythagorean identity that already had it in terms of cotangent. And so my cosecant of t without the square is equal to the square root of cotangent squared of t plus 1. Also, since cosecant is 1 over, right, if we go back, cosecant is 1 over sine, well, since I'm in the third quadrant, and cosecant is negative in the third quadrant, because the y is negative in the third quadrant, that means my cosecant of t has to be equal to the negative value of cotangent squared t plus 1. Whatever that value may be, we don't have to figure out that value. We just have to have cosecant in terms of cotangent, and in this case we have just cotangents, and we've taken care of the fact that it's in quadrant 3 by making it negative, since sine is negative in the third quadrant. And the last one, we have secant of t. So if we go back to our identities, you can go back and check. You'll see that secant of t is equal to 1 over cosine of t. And since we know the secant to be 2, right, we can determine that the cosine of t is equal to 1/2. Right? If we multiply both sides by cosine of t divided by 2, or we can simply switch this answer with the denominator here. Either way, you're going to get a cosine of t equal to 1/2. So now that we know the cosine of t is equal to 1/2, we're going to use a Pythagorean identity, a different one, that cosine squared t plus sine squared t equals 1. So I know my cosine squared t is 1/2 squared, and I do not know what sine squared t is. So 1/2 squared is 1/4. And if I subtract the 1/4, I get sine squared t equals 3/4. and now I take the square root to get a sine t, which is what I was solving for. A sine t equal to radical 3 over 2. However, remember when we take the square root, it's the plus or minus version, so we have to know which one we want, whether we want the plus or the minus. And since in the directions they told us sine was going to be less than 0, so sine is negative, I want the minus radical 3 over 2. So far I have the sine of t, I have the cosine of t, and I have the secant of t, which they gave me. I now need to find the tangent, the cotangent, and the cosecant. So if we go back to your identities, you'll see that the cosecant of t is equal to 1 over sine t. Since we know sine t is equal to that, we can figure out that cosecant t is equal to, well, since it's 1 over, I'm just going to say the reciprocal. It's equal to negative 2 over radical 3. But just like I said in class today, we can't have a radical in the denominator. So to rationalize it, I just multiply by radical 3 over radical 3, and I find my cosecant of t to be a negative 2 radical 3 over 3. So now I've found my cosecant of t. Next thing I want to do is find my tangent of t, which is equal to sine t over cosine t. I know the sine t to be radical 3 over 2, negative. And I know the cosine to be positive 1/2. So if I do that division, I can flip and multiply, and I get a negative radical 3 for my tangent. So the final thing I need to do is the cotangent, which is 1 over the tangent. Okay, so that's 1 over negative radical 3. But again, I can't have a radical in the denominator, so I'm going to multiply by radical 3 over radical 3, and I get an answer of negative radical 3 over 3. So, when the question asks for find the values of all the trigonometric functions, well, I found the cosine from the secant that was given, so there are 6 in all. So I found the secant to be 2, they gave me, cosine to be 1/2, I found sine to be radical 3 over 2, negative, because the directions told us sine was negative. I found the cosecant to be negative 2 radical 3 over 3, tangent to be negative radical 3, and the cotangent to be negative radical 3 over 3. So those are the 6 trigonometric functions that you would need if they ask a question such as that. And that's all the examples I have, so go ahead and try the example problems on the PowerPoint, and we'll discuss it in class tomorrow.